Okay, so the topic of this video will be the process of dehydration synthesis versus hydrolysis. Let's get started. So let's start in the blue area with dehydration synthesis. It's a chemical reaction that's going to bond multiple monomers into a single larger polymer. Monomers are just building blocks, small carbon organic building blocks. And in my animation, I've got three hexagons labeled the word monomer. And what we see here is in a dehydration synthesis reaction, two monomers are brought together, and it's called dehydration because I've just highlighted two H's and an O. It's called dehydration because in this process, water is going to be removed, and you know the formula for water is H2O, two H's and an O. So here we go, 3, 2, 1. Notice how a water molecule was lost, and those two monomers were bonded together. They were built or synthesized to make a larger molecule, and that's where the word synthesis comes from. Let's do that one more time. Let's bring in this third monomer, and again it's a dehydration reaction because I've highlighted two H's and an O. This is going to be water in 3, 2, 1. So a water molecule is removed, and the monomer, all three monomers have been bonded together to make one larger polymer. That's a dehydration synthesis reaction. Now, in the world of carbohydrates, the monomers are called monosaccharides. So here's three monosaccharides. They're brought together, and in a dehydration reaction, water is removed, and those two monosaccharides have been bonded together. This is now a disaccharide. But let's bring in the third monosaccharide. In a dehydration synthesis reaction, there's the two H's and an O. The water is removed, and all three have been bonded together to make a larger polysaccharide. In the world of proteins, the monomers are called amino acids. So here's a couple amino acids that are brought together. There's the two H's and the O. Water is removed, and the two amino acids have been bonded together. Let's do that for the third amino acid. The third amino acid is brought over, two H's and an O, form water. Water is removed, and all three amino acids have been bonded as one larger polypeptide. And eventually this polypeptide would twist and fold and wrap to become a protein. In the world of nucleic acids, many nucleotides will bond to make a nucleic acid. So let's bring together two nucleotides. There's two H's and an O. Water is removed, and the two nucleotides are bonded together. Let's do that one more time. The third nucleotide is delivered, two H's and an O. Water is removed, and all three nucleotides have been bonded as one larger nucleic acid. And in the world of lipids, lipids are actually built from one part glycerol and maybe 2 or 3 fatty acids. In this case, there's 2 fatty acids. And so look at the first fatty acid. It comes over by the glycerol. And notice 2 H's and an O. Water is removed, and the fatty acid has bonded to the glycerol. Let's do that one more time. The fatty acid comes over, and 2 H's and an O. In a dehydration synthesis reaction, water is removed. And now this entire unit is now a lipid, one larger lipid. So dehydration synthesis builds larger molecules out of smaller parts. So in the blue side, again, is dehydration synthesis. In the summary picture, you can see 3 monomers are being built into a single polymer. Let's focus our attention on the bottom, labeled hydrolysis. This is a chemical reaction that's really just the opposite, that breaks down a larger polymer into multiple monomers. So in my animation here, we're going to see that hydro should imply the addition of a water molecule. And lysis means to break down. So with the use of water, watch what happens to the monomer on the left. 3, 2, 1. The monomer on the left has been broken away from the others. This is a hydrolysis reaction. Let's do that again. Let's add another hydro for water, and lysis means to break down. 3, 2, 1. The monomers have been broken apart. So we started with a single polymer, which has been broken down into 3 individual monomers. Now, if we're looking at carbohydrates, this is how a single polysaccharide, that's what we have here. We have one large polysaccharide, but with the addition of a water molecule, can be broken down into monosaccharides. Let's do that again. With the addition of another water molecule, we can break those two apart. So now we have 3 monosaccharides that were broken down from the one starting polysaccharide. So in the case of a polypeptide, that's what we have here. We have a single polypeptide, one larger polypeptide. Well, that can be broken down into the individual amino acids. And so with the addition of a water molecule, the amino acid on the left can be broken apart from the others. And let's do that one more time. With the addition of a water molecule, the other amino acids have been broken apart. So we started with one single polypeptide, but now we have 3 individual amino acids. Again, that is a hydrolysis reaction. In the case of nucleic acids, a single nucleic acid, that's what we have right here. One larger nucleic acid can be broken down into many nucleotide monomers. With the addition of water, the nucleotide on the left can be broken apart from the others. Let's do that one more time. With the addition of water, the other 2 nucleotides can be broken. So we started with a single nucleic acid, and we ended up with 3 nucleotides. And lastly, the same is true for lipids. One single lipid can be broken down. That's what we have right here. We have one larger lipid, but it can be broken down into the glycerol and the fatty acids. With the addition of a water molecule, 3,2,1, the fatty acid on the bottom has been broken away. Let's do that one more time. With the addition of a water molecule, now the fatty acid on top has been broken away. So the glycerol and the 2 fatty acids have been broken apart in a hydrolysis reaction. So here's a little practice quiz. And if you want, pause the video, try to answer these questions. I hope you found this video helpful. Thank you for watching.